I'm using this one as a polynomial. So this is question 3. And we're going to go through how you would sketch it. Now, I won't do all the steps because each question takes a fair chunk of time if I did that, and I wouldn't be able to get through all the details. So I want to focus more on the derivatives and the max and mins and stuff like that, and I won't go into the concavity because if you know how to find increasing and decreasing, it's very similar math to find concave up and concave down. So here is our first function. And I'm going to call this f, I'm going to call this g. And so what I can see is to get the first derivative, that it is going to be f dash g plus f of g dashed. And that's going to be 1 times x minus 4 squared plus x times. If you differentiate x minus 2 squared, isn't it basically just a chain rule? So it's 2 lots of x minus 4 times the derivative of the inside function, which is actually just 1. So what I now have is x minus 4 squared plus 2x, x minus 4. So far, so good? We're comfortable with that? Right, style points. Factor the heck out of it is basically what we're going to be doing. In this case, it is a common factor, but it's not the one that you're most commonly going to see or more typically see. Do you notice that x minus 4 is a common factor? So if you pull x minus 4, one of them out as a common factor, you're left with plus 2x on this side and then x minus 4 on this side. And then if you tidy that up, you now have x minus 4, 3x take away 4. Are you comfortable about how I did that factoring? I pulled out x minus 4 as a common factor. That left one of these x minus 4s and a 2x. And you add these together and you got that. So first derivative done. They're going to be a critical number at 4. Right, that's what makes this 0, and you make this 0 when x is 4/3. Oops. So I'm going to do x here. I'm going to do a 4/3. 4. Something like that. And something less than 4/3, how about 1? Something between here and here, how about 2? And something bigger than 4, how about 5? So I've decided that I'm going to use those guys. I'll do a first derivative and I'll do the shape. I'll go over to my calculator. I'll put in the derivative, which is x minus 4, so bracket x take away 4, and a 3x minus 4. That's that done. I can go straight to the second table, delete the old stuff, and put in 1, 4/3, 2, 4, and 5. And what have we got? Here the answer is 0, and here the answer is 0. It's then a +3, a -4, and a +11. So what do I have? I have a positive, a 0, a negative, a 0, and a positive. So I can draw my little number line, as we've done quite a few times. Only put the values that make the critical numbers in. Here it's 0, here it's 0. Over here it is positive. In the middle it's negative, and over here it's positive. So far so good? Now, I know where it's increasing, I know where it's decreasing. I'm only interested in sketching it, so I'm just going to focus on what's happening at the critical numbers. So at x equals 4/3, the derivative is positive, so it's sloping up. then it's 0 when you use 4/3, and then it goes negative. So that is a local max. If I go to x equals 4, it's what? Slope them down, horizontal, slope them up. That's called a local minimum. Now I need to know the coordinates of this. So this guy is x coordinate is 4/3. I'll find what its y is in a minute. And this guy is 4, and we'll find out what its y coordinates are in a moment. Now, if you want to find the y coordinates, you plug 4/3 into here, and you plug 4 into here. If you plug 4 into here, I know that one is 0. If you plug 4/3 into here, it's going to be a bit messy, but let's try it. It's going to be 4/3 times 4/3 take away 4 all squared. Oh, I made a mistake. No, I didn't. I don't like the answer, but maybe it's a nicer fraction. Oh, okay. It's 256 27. So I wouldn't call that a nice fraction. Let's find out what that is as a number. 256 divided by 27. It's about 9.5. Now, if I was going to draw a sketch of this, I would find the point 40, which let's say it's here. And I'd find the point 4/3. What's that 1/3 about here? And then 9.5 is up here. So I know there's a local max up here and a local min down here. Actually, don't I pretty much know the shape of the graph by now? Right. Local minimum at 40, local maximum at 4/3, 9.5. And if you put that into Desmos, that would be the shape. Are we comfortable with this process of just using the first derivative to do most of the work? Now, there are a couple of other things I could have found, which I didn't. Couldn't I find out where the x-intercepts are, which is at 0 and at 4? So actually that shape that I did there, it would go through the origin, so it would be a little bit steeper. The rest of the shape would be fine. Now I've got an even better sketch, don't I? I know where it crosses the x-axis, and I also know local max and local min. Are we good with that? Okay, next one is horrendous. Fractions just have everything that can go wrong, tends to go wrong with these guys. So this one's going to take me a fair amount of time to do. So I'm glad we've got 2 days to do these questions. I'm going to do x-intercepts, y-intercepts, local max, local min, and because it's a fraction, don't you also very often get vertical asymptotes, right? So this shape is pretty much going to have every feature a graph could have, including vertical asymptotes. First thing I'm going to do is factor it. And I'm really glad that I factored this one. Does anybody see any simplification that could be done?
Divide by x plus 7, 7 plus x.
Yeah, because it isn't x plus 7 and 7 plus x actually at the same time. So that was worth doing, because all I need to do is sketch that guy. And would you agree, anything that's simpler is going to be easier in the long run, right? That fraction is going to be a lot easier to differentiate and all the other stuff, right? Now, you might wonder, is that allowed? Well, it is allowed, but there is a little provision. When you simplify an original fraction down to this fella, x plus 7 gets killed off. That means that x negative 7, just at one point, is undefined. And what does that mean? When you draw the sketch, there's going to be a little hole there, right? So can you imagine this is x equals negative 7, right? It's not a vertical asymptote, right? Because the top and bottom cancel. It's just going to be a tiny little hole. So you won't even notice it when you sketch it. But if just for completeness sake, shall I put that in that you are allowed to do this, but realize that what it does is it pokes a hole in the curve at one particular point, right? Nothing else special apart from that. So let's go for x-intercept. Well, if you want to find x-intercept, you need to solve when is the function 0. In this case, you need to solve that. When you have a fraction equal to 0, the top is 0. So guess what? We've just found the x-intercept. It's at the origin. So I'll put my little guy here. And it has an x-intercept at the origin. Wouldn't also that be the y-intercept? Because there's only going to be one y-intercept, so it's the origin as well. So now we're going to go looking for local mins, local maximums. Right. Well, I'll do that first, and then we'll talk about the vertical asymptotes. Actually, let's change that a little bit. Would you agree that this function has a vertical asymptote? At what value of x does the vertical asymptote happen? Remember 141 when you're done rational functions. What value of x is the vertical asymptote going to happen?
X equals 7.
Right. It happens when the bottom is there. So 1, 2, 3, 4, 5, 6, 7. Now at x equals 7. This curve is going to have a vertical asymptote. And you know the kind of shapes you get with vertical asymptotes, don't they? Sometimes look like mountains, sometimes they look like holes in the ground, sometimes they look weird, but at least I have that. So that's out the way. I now know where my vertical asymptote is. So vertical asymptote at x equals 7. Done. Right, now look for local max and min. I'll need a new page to start this off. I'll begin with our simplified fraction. And I'll find its derivative. This is definitely a quotient rule. So we'll call the top f, we'll call the bottom g. So it's going to be f dash g, take away f of g dashed, all over g squared. Differentiate that, you get 1, leave the g alone. Leave the top alone, and differentiate by that, which just gets you -1. All over the bottom squared. That's 7, take away x. That is, oh, an x, take away another x. That is plus x. I was not expecting this, but you never know what you're going to get until it happens. That came out a lot simpler than I thought it was. I wasn't expecting the x's to cancel, but it can happen, and it's happened here. Well, that's fine, except the answer's going to be a little bit weird. What we now do is we find critical numbers, and there are two kinds. When the derivative is 0 and when the derivative is undefined. Well, I know when this expression is undefined. Isn't it going to be undefined when the bottom is 0? And the bottom is 0 is going to happen at x equals 7. And then I say, well, that's not a surprise. There's a vertical asymptote there. Wouldn't you expect something weird to be happening? So that matches exactly what I was thinking. What is a little bit strange, because this doesn't happen very often, is that if you want to find out when the derivative is 0 and the thing is a fraction, then isn't the top got to be 0? But in this case, there are none. So there are no critical numbers that make this derivative 0. There are no values of x that this fraction is 0. Which means that my table of signs is going to be really small. It's going to be x. There's going to be a 7 in it, because that's one of my critical numbers. I'm going to pick 6. I'm going to pick 8. I'm going to put the value of the derivative, and then I'm going to do the shape. Go to my calculator, type in the derivative, which is x divided by, put a bracket around it, 7 take away x. That bracket is important, it's not cosmetic. If you just do that calculation without the brackets, it's not the same thing. Now I should be able to go to second table, rub out the other stuff, and put in 6, 7, and 8. Now the calculator describes undefined as error, but we'll call it undefined. And on the 6, it's a 6, and on the 8, it's a -8. So this is positive, and this is negative. Now this is not a local max, this isn't even a local min. The reason for that is that that is not 0. It's not up, flat, and down, right? This is actually a vertical asymptote. So I'm going to go to my picture and see if I can figure out how to use this information to draw the type of vertical asymptote I'm getting. Here are some of the possible things that might happen. Couldn't I get a vertical asymptote that looks like that? I call these volcanoes. That's my name for it. Couldn't I get a vertical asymptote that looks like that? I call those ones holes in the ground. And then I could get a vertical asymptote where it goes up on this side and then it curves down on that side. And then there's a kind of symmetric version of that where it does the opposite. It goes down and then it's up. One of those 4 corresponds to this information. Right? And I'll give them numbers. This one's number 1, this one's number 2, this one's number 3, and this last one down here is number 4. Which one of those 4 pictures gives you a climbing up and then a climbing down?
3.
Let's check it. Let's check out 3. So actually I'll start at 1 and go through and we'll see if 3 works. If you take any point on this curve, would you agree the tangent line is positive? So this would be positive, undefined. And what about any point on this side? What would that be? What that? Positive or negative tangent line?
Negative.
Oh, isn't that this one? So what we have is it curves up on this side and it curves down on that side. Now, if you got this situation, let's see what the combination is. It would be negative, undefined, positive. The one that you said, and I can understand because it looks like it's doing 2 things, so one's plus and the other's not, but actually aren't both of these pluses. On this curve isn't all the tangents plus, but even in this one, and forget about the pointing downwards, that's a distraction, it doesn't tell you anything. Is it the curve sloping upwards from left to right? You always do it that way. And this last one then, it would be a negative and a negative. So there are 4 things that can happen. This one happens to be that. So now I know that much. Now, what's left in a rational function, once you've figured out all the local max and mins and vertical asymptotes and intercepts, which is what we've got here, is that you go for horizontal or oblique asymptotes. The original function was called x over 7 minus x. That's the distractions over. I mentioned to some of the people I was in earlier that we were having issues with our heat pump, and there was a techie guy fixing it. So I might as well share. Do not put a high allergen air filter in your heat pumps, because evidently they clog up too quick and they stop the airflow. And airflow seems to be a bad thing when you've got when you've got the guy we've got. So basically, I spent too much money on an air filter. I should have been using the cheapo ones because they let more air through. So go figure out the logic of that. But at least it's fixed. So horizontal or oblique, how do you find them? We find them by finding the limit as x tends to infinity of f of x. So in this case, we are going to find our new friend. Remember L'Hopital? And wouldn't that be infinity over some kind of infinity? So I know I can do it. So it's going to be the limit as x tends to infinity. Differentiate the top, differentiate the bottom. Oh, -1. That means that we have, let's make that -1. We have a horizontal asymptote at -1. I think I'm finished. Let's see. It has to level off. And then it has to go through the origin. I know there's a little kink there, but pretend there's not. And level off. Would you agree that fits all the information that we got from this curve? And if I had time, which we don't kind of have now, I would put that into Desmos. And if you adjusted the scales, you would see exactly what we've got here. So we can use calculus to sketch rational functions. Any questions? Are we good? We're not good? Or we have no questions? No questions, okay. Let's continue the story. That one was a lot nicer than I thought it was going to be. Oops, where is it? I've lost it, didn't I? That one was a lot nicer than I thought it was going to be because it's simplified. Typically, those guys take forever and a day. Can you imagine it had 2 guys in the top and 2 guys in the bottom? You could have had all sorts of different critical numbers in a huge table. This one kind of disappeared almost into nothing. I have no idea what 7's going to do. All I chose it was because it had a square root in it. And so we are going to be looking at this guy. Can you trust me that its x and y intercepts happen to be the origin? I'm not even going to do that one. That one's easy to do. Right, now I want to differentiate it. And I've done enough derivatives in my life to know that square roots are not the way to go. Right, you have to call it a half power. Would you agree that this is a product rule situation? Right, I want to differentiate this. I need to do a product rule. So this is going to be my f, and this ugly thing is going to be my g. So the derivative is going to be f dash g plus f of g dashed. It's going to be 1, right? Leave this guy alone. Plus x. And now I'm going to differentiate this guy. This is a chain rule. 5 minus x squared to the power of half, its derivative will be a chain rule. So I'm going to multiply by the power. I'm going to reduce the power by 1. And then the derivative of the inside function. And when you differentiate 5 minus x squared, you get negative 2x. So I have a 5 take away x squared to the half. That guy times that guy times that guy times that guy. That whole mess ends up being negative x squared, 5 minus x squared to the negative 1/2. Okay, now there are two different approaches to factoring this, right? To doing style points on it. I'm going to show you both methods, and then you can figure out which of these two methods you like for situations that end up looking like this one. Right? The first one is basically the longer of the two. Are you happy with that, Chi, as a square root, and this becomes a square root in the bottom? Are we comfortable with that one? Now, I have a guy that's not a fraction. Subtract a guy that is a fraction. I need these to go together, right? I need to have a single fraction. So what I'm going to do now is I'm going to take this fella here, and I'm going to multiply it by a special version of 1 so that it matches this fraction. And the special version of 1 I'm going to use is 5 minus x squared inside the square root. Now, do you notice that both these fractions are now going to have the same guy in the bottom? That's why I chose it. Now, if you now have the same denominator, this guy times this guy is actually just 5 take away x squared minus an x squared. And so we have a derivative that is 5 take away 2x squared all over 5 take away x squared. Do you follow that process? How we got this ugly mess to become a single fraction. We have to make it a single fraction if we're going to do anything else from this point onwards, right? What I call style points. Do you want to see the other method, or are you comfortable with this one? Because sometimes showing people two methods isn't as much help as I think it's going to be. Do you want to see a different way of tackling that question?
I would like to see the other method.
Right, and if you don't like it, just ignore it, right? Forget I ever told you. And if you like it, ignore this method, I guess, right? So you're focusing on just one. So I'll return back to the point that we had, which looked like this. And the second method involves using a common factor. Would you agree that both these contain a common factor of 5 minus x squared, right? This one has a half power of it, and this one has a negative half power of it. Do you agree? So I'm going to take out 5 minus x squared. Now, when you usually have a common factor situation, you know, like if I had an x squared and a 4x to the cubed, don't you always take out the smaller of the two powers as your common factor? So if it was this one, I would take out x squared. Right. I have a common factor. One is a half power, the other is negative half power. So I will take out the smaller of the two, which is the negative a half power. Now, that guy uses this one up, so that guy is negative x squared. Here's the weird one. I have a half power, and I'm going to take away a negative a half away from it, right? Because basically that's what you do, right? You take the power and you subtract this. So a half take away a negative a half is actually a half plus a half, which means you get 5 minus x squared to the power of 1. And you now have that guy, take away that guy, which then becomes that guy. Try and do this a little bit again. We have 5 minus x squared to the half if you take this guy out as a common factor, the guy that goes here is a half, take away that. So it's 5 minus x squared, right? 1/2, take away negative a half gets you plus a half. And I'm saying that is 5 minus x squared to the 1. Now, if you write them next to each other, if you multiply them together, don't you get the original? You see, it does work. So this one involves less stages, but you're going to have a real issue of making sure you do this bit right, right? You take out the common factor, the smaller, and it's figure out what that becomes is going to be your big hullabaloo. Do you like the setting method, or you wish I hadn't shown you? Like, any?
I'm glad I saw the second method, but I do prefer the first one.
You don't know until you see it. I agree. Okay, so I'll just rewrite this guy. Now, there are going to be a change to my answer, but I'm going to go through it as if I didn't know there was going to be a change. Critical numbers happen when the derivative is 0. Critical numbers happen when the derivative is undefined, right? Now, when a derivative is 0, we're trying to solve that, right? And we've talked about this before. When you have a fraction, don't you only need to worry about what makes the top 0, right? And if you do a little work on this, I wish I'd give myself more room. Let's rub this out so I can keep going. You get 5 over 2 is x squared, and that makes x plus or minus the square root of 5 halves. Don't worry about the fact it's an ugly number. It's a number, right? Which superficially looks like there are 2 answers, 2 critical numbers, because very often there are 2. But that one is not going to get used. Let me check that. Oh, I take it back. That one's okay. I'm okay with that one. I tell you why I was thinking of killing it off. Don't things inside square roots have to be positive or you can't evaluate them? Agreed? Things inside square roots have to be positive. I thought that one was going to generate a number that didn't work, but I'm looking at it now and it's okay. So they 2 are fine. Now, when is the second derivative undefined? Well, it's going to happen when this is undefined, but that becomes this guy, right? And when is this guy 0? Well, this guy is going to be 0 when that is 0. And that's going to happen when x squared is 5. And so I'm going to have plus or minus root 5. And so that gives me a plus root 5 and a negative root 5. And all of those work, so I'm cool with them as well. So that means we have, in total, 4 critical numbers. 2 places where the derivative is 0, 2 other places where the derivative is undefined. So in order, negative root 5, then a space. Then after that, it's going to be negative root 5 over 2, then a space. And then it's going to be positive root 5 over 2, then a space. And then it's going to be positive the square root of 5, and then a space. Good grief. This is huge. Right, what do I know? At this point here, the derivative I know is going to be 0. At this point here, I know it's going to be 0. And at these 2 points, I know they're going to be undefined. So I didn't even need my calculator for that. But here we go. I'm going to put in our derivative, which is this fella. So I'll put a bracket around it. 5 take away 2x squared divided by the square root of 5 minus x squared. And then I'll go second table. Get rid of all those guys. And I'm going to put in some numbers. How about, that's 2 and a bit, so I'll make that -3. Okay, what's that? 2 and a bit, I'll make that -1. I'll make that 1. I'll make that 3. What's that going to be? I better be careful here. Make that 0. That's better. Make that 1. Make that 3. Okay. So, -3. Oh, error. Of course. If you put in -3 here, won't that guy be a negative number? So those guys don't count. Oh well, I found some. And those guys won't count. Right, now I can do the rest. I already know that one. -1. Negative, yikes, square root of 5 divided by 2. Oh, I already knew that was 0. I guess I didn't need to do that one. 0, 1, and the end one doesn't matter, but just to show you, there'll be an error, right? So errors are basically the calculators tell me the function doesn't exist at the extremes. And at -1, I get 1.5. At 0, I get 2.2. And at 1, I got 1.5. So I have an undefined, positive, 0, positive, 0, positive, undefined. God, that's going to be a weird shape. Negative square root of 5 is a critical number. Negative the square root of 5 halves is a critical number. Positive the square root of 5 halves. And finally, that guy. And that's the start and end of this function. It doesn't exist anywhere else. And here I have a 0, here I have a 0, and it's undefined at the 2 endpoints. And it looks like everybody is positive. That is one weird answer. I'm going to check this guy in Desmos because it's going to go positive, 0, positive, 0, and positive. It looks like it's going to snake upwards, doesn't it? That is weird. Right, let's find out what Desmos tells me about this shit. Because it's just very hard for me to imagine a shape that would do those things. Right, okay, let's click over. Let's see if the original function, which is this one, has this kind of climbing snake shape. I don't know what else to call it. X square root of, okay, square root of 5 take away x squared. And I did something wrong. I got the origin thing right. And it goes negative, positive, positive, negative. So where did these guys come from? 5 take away 2x squared? Yeah, that should be fine. Did anybody see a plus turning into a minus here? because I can see right now that my picture, which is a climbing thing, is not right. If I wanted the picture to be correct, this number here would be negative. Right, everything, and this one here would be negative as well. So let's check. 5 minus 2x squared. I cannot explain what I screwed up. Come on, guys, help me out here. I'll show you my notes and you tell me where that plus that was a minus. The mistakes are these two guys should be negatives. Everything else is fine, but those two guys should be negative, and I didn't get a negative. Now, if I plug what I've got here, I can tell that this equation is telling the truth. So this must be wrong.
Or when you do f of x equals 0, shouldn't it have been plus or minus the square root of negative 5/2? Because we're evaluating 5 minus 2x squared equals 0.
Right. I think that's these two here, isn't it?
But I'm saying shouldn't there also be like a negative on the inside of the square root?
Ooh, like here and here. That would not be nice. Let's find out. Yeah. I should never have other things happening. I'm not good at multitasking. I can't think straight at the best of times. Right. Now, if we want to make this 0, right, then we need to solve that guy. And so, just going through my working, that guy, and then the plus or minus comes after you do the square root. So I don't see a negative inside. I think
The way that I had did it, the 5 minus 2x squared, I put the 5 on the other side.
Oh, okay. So if
Yeah, I don't know. I was
no, I even if it's not right, at least we're thinking about. But then when you divide, the answer ends up being back to being positive again. Because 2 negatives divide would give you a positive. Now, the mistake must be happening before here. Okay. F dashed, leave it alone. Nothing wrong with that. 5 times, nothing wrong with that. Minus, minus, good. Minus, good. 5 minus x squared, good. Half, reduced by half, that's good. Minus 2x, that's still good. Do they cancel? Yes, they do. Do they cancel or combine? Yeah. Do you get a negative out of it? Yes. So I have this guy take away that guy. Right, I give up. Okay. I am going to, because it's going to drive me crazy, I am going to do question 7 again from scratch. And once I figure out what the heck it is, I'll put it as a PDF and you can all go and have a look at it and see what I've done wrong.